Hello students. So in first lecture of this disconnection approach, I gave you the introduction in which I tell you about some terms which are used in this disconnection approach. For example, what is target molecule, disconnection, retrosynthetic analysis, synthon, synthetic equivalent, and functional group interconversion. So in this lecture, I will tell you little more about those terms. So what is this synthon and synthetic equivalent? So let us discuss more about this synthon and synthetic equivalent. So what is this synthon? Synthon are the ionic species which are formed, which are obtained after disconnecting a target molecule. Okay, so ionic species obtained after disconnecting a target molecule. Okay, so these are the ionic species obtained after disconnecting a target molecule. Now, what are synthetic equivalent? Synthetic equivalent are the neutral species which are obtained from synthon. Neutral species obtained from synthon. So let us understand this with the help of certain examples. Okay, so synthon and corresponding to this synthetic equivalents are obtained. For example, suppose if you get alkyl cation. So alkyl cation, after disconnecting a target molecule, if you get the alkyl cation, so corresponding to this alkyl cation, what synthetic equivalent you will write? You can write alkyl chloride or alkyl bromide, alkyl iodide, alkyl toxylate, or we can write alkyl chloride in presence of AlCl3, alkyl bromide in presence of AlCl3, like this. So this is synthon, ionic species, and this is the neutral species which is obtained from this synthon. After adding some, suppose if this R plus is there, you will add a Cl minus to it, okay, or OTS minus to it, or this RCl in presence of alkyl chloride in presence of aluminum chloride, it will generate this alkyl cation. So this alkyl chloride, aluminum chloride, it will polarize this chloride ion and it will generate a alkyl cation. Now suppose if we have alkyl anion, so corresponding to this, the synthetic equivalent that you will write, Grignard agent. So all of you know this Grignard agent, it produces a very good nucleophile. So R minus Mg plus. Okay. Now suppose if you have OH minus, so corresponding to this you can write NaOH, or sometimes you can write H2O also. Suppose if you have a ethoxide ion, so corresponding to this, the synthetic equivalent that you will write, sodium ethoxide. Okay. Suppose if you have a cyanide ion, then you can write NaCN, KCN, okay, HCN in presence of copper cyanide. So this can produce the cyanide ion. Now if you have suppose chloride ion, so corresponding to this chloride ion, or if you have a bromide ion, corresponding to this you can write NaBr, KBr, like this. Suppose if you have acetylide, alkyl acetylide, so corresponding to this, what synthetic equivalent you will write? So this can be generated, this in presence of base. So base will abstract out this acidic hydrogen from here, and it will give the alkyl acetylide. So this can be generated in presence of copper halide catalyst. Okay, similarly, suppose if you have a bromonium ion or chlorinium ion. Okay, so it can be generated this in presence of AlCl3. In presence of AlCl3, so this will, the chlorination of this aromatic ring takes place by this electrophilic substitution reaction. So similarly, suppose if you have a nitration, for this nitration you need a nitronium ion, and it can be produced from nitrating mixture HNO3 plus H2SO4. In the same way, sulfonation can be done in presence of H2SO4. This H2SO4 produces this SO3 plus. Okay, some more synthon and their synthetic equivalent. Suppose if you have this one, positive charge is present over here. So corresponding to this, you will write the synthetic equivalent carbonyl compound. Now, suppose if you have so corresponding to this, the synthetic equivalent that you will write similarly, suppose positive charge is present over here. So in this case, the synthetic equivalent that you will write now, suppose the positive charge is present over third carbon from carbonyl carbon. Suppose positive charge is present on the third carbon from carbonyl carbon, first, second, third. And in this case, you should remember the synthetic equivalent that you will write, the double bond will be there on second and third carbon. Now, suppose if you have a synthetic equivalent, synthon is this, then corresponding to this, how negative charge can be generated over here? So this can be generated in presence of some base. So base will abstract out this acidic hydrogen, or you can write the synthetic equivalent for this active hydrogen compound. So in presence of this active hydrogen compound and this is base, now here this negative charge can easily be abstracted out from this carbon. Okay. Now suppose negative charge is present over here, then what should be the synthetic equivalent? The synthetic equivalent that you will write, this is similar to this R minus, so MgX. So you can write here MgX positive, here is negative, like this. So one of the important examples, suppose if you have a positive charge present over here. So in this case, the synthetic equivalent that you will write, epoxide ring that will be formed. Okay, so this epoxide ring that will break from here and it can produce again this positive species. So these are some of the important synthon and their synthetic equivalent that you should remember. Okay, now let's take some example in which these synthon and synthetic equivalents are formed. Okay. Now suppose I take one of the dicarbonyl compound. Suppose I take 1,3-dicarbonyl compound. So I can suppose give a charge minus, plus, minus, plus, minus. So I can disconnect it from here. So this is the disconnection arrow. Above this disconnection arrow, as this carbon-carbon bond is disconnected, so you will write carbon-carbon, carbon single bond carbon, and the synthon that are generated, positive charge over here and negative charge over here. Okay, so corresponding to this synthon, the synthetic equivalent that you will write, so corresponding to this synthon, this is the synthetic equivalent. Corresponding to this synthon, the synthetic equivalent that you will write is this. So this is equivalent to Cl plus AlCl3, and for this you will write the synthetic equivalent, this, in presence of base or some, either you can write this one also. Okay, so if we react this one, these two, then you can get this target molecules. So the synthesis of this is written in reverse direction. So this is the retrosynthetic analysis of this dicarbonyl 1,3-dicarbonyl compound, and if you want to write the synthesis, then you will write in a reverse direction. Similarly, suppose I take 1,5-dicarbonyl compound. Okay, then so this will have the positive, negative, positive, negative, positive charge. So after disconnecting it, you will get the synthon, negative charge. Here you will have the positive charge. So what will be the synthetic equivalent corresponding to this? So corresponding to this, the synthetic equivalent will be this. Either you can write this one or this, in presence of base, and corresponding to this synthetic equivalent, synthon, you will write this synthetic equivalent, means this first, second, third. When the positive charge is present on third carbon from this carbonyl carbon, then double bond, you will write the double bond on second and third carbon. Okay, so like this. Now suppose next example, suppose if you have a tertiary alcohol, you have a tertiary alcohol, then how you will disconnect it? Suppose I disconnect it from here, then so corresponding to this, you can write the synthetic equivalent carbonyl compound plus this RMgX. Okay. Now one more example. Suppose if you have now suppose this is the molecule, and if you want to disconnect it, suppose I disconnect it from here. Okay, then negative charge, this will have a positive charge, this will, now for this one, this is the synthon, this is the synthon, NH minus. Now corresponding to this synthon, what synthetic equivalent we can write? So this is same as this. So we will write we will give a epoxide ring. So I am writing here the synthetic equivalent of this. This is the synthetic equivalent, and corresponding to this synthon, we can write the synthetic equivalent NH2. After adding H plus, you will get this synthetic equivalent. So this is about the synthon and synthetic equivalents. Now in next lecture, we will see the functional group interconversion and their example. Thank you.